the dimensions of our whole project is 1 meter times 0.5 meter. Here we can see the green square that measures 60 centimeters times 50 centimeters. Here we can see the black and gray square that measures around 25.5 centimeters times 50. Here in the levels, in the first level, it is at a height of 50 centimeters and the pathway measures 71 centimeters at this height. When it's at the second level, the height is 25 centimeters with a pathway of 73 centimeters. The last level measures 41 centimeters of height and the pathway is 79 centimeters. We have that the car measures 8 centimeters and it weighs around 0.03 kilograms.
Okay, so the purpose of this project is to make a device so we can teach students from junior high that are having the course of physics, the introduction of physics, and to teach them the basic laws of Newton, the second and third, which is force equals mass times acceleration. Each action has the same reaction with the same magnitude and opposite direction. And while this grade is also for the students of junior high to review last topics that they've seen before.
It's basically all the concepts related to physics and mathematics. We use several formulas to get our measurements, especially with the kinematics formulas. We can get the final velocity, the acceleration, the time, the distance, the initial speed, and that's it. We can get some data through mathematical formula related to topics of Pythagorean theorem to get the angle. Also, we can get the slope of the line equation. We can get the angle and cosine of the angle, sine, the tangent, and more equations. Also, this project is mainly about the second and third law of motion. The second law of motion consists in force equals mass times acceleration. And the third one is a statement that establishes that every action has a reaction with same magnitude but opposite direction. The most important formulas is the formula of momentum and impulse. The formula of momentum consists in mass times velocity. The impulse consists in the difference between momentum initially and final momentum. And the most important formula is the one that has force times time that is equal to impulse.
Okay, so in this experiment we have two planes. The first one is an inclined plane where the car will move down and will accelerate. The second plane, the car will go in a constant speed. That will be the final speed of this plane will be the initial velocity or speed of this one, and then we'll impact the wall and go back. Okay, the formulas that we use for the experiment is first we calculate the acceleration that the car will get, and by doing this we use as an example free fall, that is sine of 90 times 9.8. We got the acceleration, and then we started getting the sine of the different angles that we had here. The angles we measured by hypotenuse over adjacent angle side, and that's how we got the angles, and the acceleration we got it using those angles. After that we got the final velocity, which was the main part of this experiment, the final velocity. And we got it with the formula final velocity square equals initial velocity square plus 2 times acceleration times distance. We measure distance from here to here, is the same as the hypotenuse. The acceleration we calculated in the previous formula, and the initial velocity is 0 because we don't have any force acting initially on the car. So we just let it go, and the gravity pulls it down the ramp or the pathway. Okay, after that we calculated the time, and the time we calculated with distance equals initial velocity times time plus half acceleration times time squared. Okay, that was pretty easy. We isolated t and got the t squared equals d over half of a, and that's how we got the time. And the second plane, which is from here to here, we had several things. We first calculated this acceleration. The way we calculated that was with the formula force equals mass times acceleration. Okay, since the mass of the car is 0.03 grams from here to here when it reaches the wall and bounces back, what we calculated was that this acceleration of the car, and we calculated that with the following equation, that is final velocity square equals initial velocity square plus 2AD. 2AD is the acceleration times the distance. We had all of those values except for acceleration, so we isolated acceleration and got this acceleration for this angle was negative 0.28 meters per second square. Okay, after that we got the friction force. Friction force, we got it with the formula of acceleration times mass of the car, and the mass of the car is 0.03 kilograms, and the force of friction will be negative 0.0084 newtons. That's where we got the friction force. That's why the car doesn't go constantly the same speed, even though it should. And also we calculated the weight. The weight of the car was negative 294, and the normal force that keeps the car here and not under the surface, which was the opposite, 0.294 newtons. Okay, after that, to calculate the force of the impact on wall, we used two formulas, impulse and momentum. We calculated the momentum with the mass against the velocity of the car. Since the mass is 0.03 kilograms and the velocity was 3.99 meters per second, we multiplied that and we got the momentum that was 0.1197 watts.
Kilograms
per
velocity
per mass per second.
per mass.
Kilograms per mass per second.
Okay.
Sorry. And after that, we use the equality of impulse equals the difference of momentum. Since the final momentum of the car is 0, the impulse will be the same as the initial momentum. Okay? Then we calculated the force of impact on the wall with the momentum using force equals impulse over time. Okay, that time we calculated using the formula T over T equals distance over velocity. That's the formula we use to calculate time from here to here. Pretty easy. And the force of impact, that was 1.7367 newtons. And why it bounces back? Because for every action, there's an equal reaction but with different direction, the opposite direction. And that's pretty much what we did in our experiment.